Okay, so we've computed the leading order and the order G term of the two-point function. Now let's evaluate the diagrams that contribute at second order in the coupling. So here they are. There's 1, 2, 3, 4, 5, 6, 7 of them. Let me pick up the first diagram. Okay, good. So let's pick up this diagram and we will evaluate what it is. So there it is. Okay, so let's see what we've got. So first of all, how many lines are there? Okay, so I'm going to count the lines now. So watch what I do. So there is 1, 2, 3, 4, 5 lines. Okay, so there's a total of 5 lines in this diagram. So we will start off with 1 over alpha to the 5. Then how many vertices are there? Well, there's one vertex there, one vertex there. So this diagram has a total of 2 vertices. For each vertex, the rule is minus g times 4 factorial. So we'll have a minus g squared and a 4 factorial squared. Now remember, 4 factorial is just 24. Okay? And now, how many closed lines do we have? So we need 1/2 for each closed line. And there's 1, 2, 3, 4 closed lines. Notice that both red lines and both green lines have the same start and end point. So there's a total of 4 closed lines. So we'll have 1/2 to the power of 4, and that is from the closed lines. Then how many equivalent lines? Well, on this first diagram, that red line over there is equivalent to that red line over there. On the second disconnected piece, this green line is equivalent to that green line. So there's 2 pairs of 2 equivalent lines. Don't tell me there's 4 lines that are equivalent, because the red lines are not equivalent to the green lines. So for equivalent lines, there are 2 pairs of 2. Okay, so for 2 equivalent lines, we have 1 over 2, and we have 2 pairs of 2. So let's say 2 pairs of 2. And then if we look, do we have 2 equivalent diagrams? Well, yes, those 2 figures of 8 are equivalent diagrams. So we've got an extra factor of 2. This is for equivalent diagrams. And then equivalent vertices. Well, no, impossible. Each disconnected piece of the vertex of the diagram has at most 1 vertex. So there's no equivalent vertices. Now notice something, okay? We know that, so let me just make a note here. We know that 24 over 8 is 3. And we also know that what we've got here, we've got 24 squared over 2 times 2 times 2 is 8. And then we've still got 2 times 2 times 2. We've got another 8, and then we've got 2. So the first 24 over 8 is 3. The second 24 over 8 is 3. So that in the end, the contribution from this diagram is equal to g squared over alpha to the 5. So that's the g's and the alphas. And then the number we've just argued is 3 times 3, which is 9 over 2. Okay? So this is the answer that we get from the first diagram. Okay, now let me erase our workings and we'll move on to the second diagram. So there was our working, delete. Now let's pick up the second diagram, which is sitting over here. Come on, copy. Oh, sorry, duplicate. There we are. Okay, good. Okay, so now let's work out what this diagram is equal to. So first of all, we need to know how many lines. So let's count the number of lines, okay? So here is 1, 2, 3, 4, 5 lines. Okay, so there's a total of 5 lines in this diagram. So the first thing that we will have is 1 over alpha to the 5. How many vertices are there? 2 vertices, 1 there and 1 there. So the 2 red vertices are there. So we've got 2 vertices, and for each vertex we should get minus g times 4 factorial. So we'll have minus g squared and 4 factorial, which is 24 squared. Good. Okay, now let's see how many closed lines we've got. Well, there's a closed line sitting over there, and there is a closed line sitting over there. So we've got 2 closed lines. We should get a factor of 1/2 for each closed line. So we will have 1 over 2 squared. Then, so this is for closed lines. Closed lines. Then we can ask, how many equivalent lines do we have? Well, this blue line over here has the same start and end point as this red line over here. So we've got a total of 2 equivalent lines. If we've got q equivalent lines, we have a factor of 1 over q factorial. So we'll have a factor of 1 over 2 factorial, which is just 1 over 2. And this is for equivalent lines. Then how many equivalent diagrams? Well, no diagram is repeated, so we don't have to bother about equivalent diagrams. Then how many equivalent vertices? Well, this vertex is equivalent to this vertex. You see, if you swap those 2 vertices, you don't change the fact that they each have 2 of their legs combined into a closed line, and you don't change where the 2 lines traveling between the 2 vertices start and end. So there are 2 equivalent vertices. So we'll also get a factor of 1/2, and this is for equivalent vertices. Okay, good. So that's the answer for this diagram. Now, what do we have? We've got 1 over 4 times 1 over 4, and I think that you know that 24 over 4 is just 6. So we're going to have a 6 times 6. So what does this diagram equal to? It's plus g squared over alpha to the 5, and then 6 times 6 is 36. Good. So we've evaluated now the second diagram. Let's move on now to the third diagram. Good. So we're taking things very slowly now, but I just want you to be able to calculate this. And the easiest way to learn this is to do a few examples. So that's what we're trying to do right now. Okay, duplicate. Good. Okay, so let's see what this is equal to. So first of all, how many lines are there? So let's check. So here we've got 1, 2, 3, 4, 5. So there's a total of 5 lines in this diagram. Lines can start or end on dots and start and end on vertices. So by now, I'm sure that you've properly understood the rule. So this is equal to 1 over alpha to the power of 5, because we've got 5 lines. We've got 2 vertices, so we'll have a minus g squared, and we will have a 24 squared. Then what do we need to start doing? Well, let's look at our rules. There's a 1/2 for each closed line. Well, none of these lines are closed. None of them start and end at the same point. There's a factor of 1 over q factorial for equivalent lines. Now look at this. This blue line has the same start and end point as that green line, which has the same start and end point as this red line, which has the same start and end point as that yellow line. So in this diagram, there is a total of 4 equivalent lines. So we will get 1 over 4 factorial. And this is for equivalent lines. And then, are there any equivalent diagrams? No, well, there's only a single diagram. And then, are there any equivalent vertices? Well, yes. If we swap the 2 vertices that we have in this diagram, we don't change where the different lines start and end. So those are two equivalent vertices. So we will have a factor of 1 over 2 for equivalent vertices. Okay, and that's the diagram. Now, 1 over 4 factorial is 24, so we cancel off 1 over 24s, and then 24 over 2 is just 12. So we get plus g squared over alpha to the 5 times by 12. Great. That's the first 3 diagrams evaluated correctly. We'll continue with the rest of the diagrams in a moment.